Let's now move from the two-dimensional shapes to three-dimensional shapes. As you encounter more challenging questions, you will also encounter more three-dimensional geometric shapes. Three-dimensional objects, or solids, have length, width, and depth. The most common solids on standardized exams are rectangular boxes, cubes, and cylinders. A line segment that connects adjacent vertices of a solid is an edge. You may be asked to find the volume of a solid or its surface area. So let's examine volume first. For the solids that you're most likely to see on your exam, you can find the volume by multiplying the area of one face by the length of the dimension perpendicular to that face. We'll look at some examples that will help make this description clear. As for surface area, a solid's surface area is the sum of the areas of each two-dimensional surface. Let's take a look at some examples. First, rectangular boxes. A rectangular box is a solid with 6 rectangular faces. All of its angles are right angles. The volume of a rectangular box is equal to its length times width times height. The surface area is the sum of the areas of each of the 6 sides. Since each side will have the same area as the one opposite it, we can find the surface area of each of the 3 visible sides, double them to account for the sides we can't see, and then add them. Let's try it with a problem. If a rectangular solid has a length of 6, a width of 4, and a height of 3, what is the total surface area? So what we're going to do is find every combination of length, width, and height we can multiply together. So what we know is that our surface area is going to equal 2 times the length times the width, plus 2 times the length times the height, plus 2 times the height times the width. So we can just plug it into our formula here. What we're doing is finding the area of each unique face of this rectangular solid and multiplying it by 2. So our surface area is going to equal 2 times our length times width. So with a length of 6 and a width of 4, plus 2 times length times height, length of 6 and height of 3, plus 2 times height times width, height of 3 and a width of 4. And now we do our math. 2 times 24 plus 2 times 18 plus 2 times 12 equals 48 plus 36 plus 24, which is all equal to 108. Let's now take what we've learned and try an in-format question dealing with solids. If rectangular box J has a length of 2, a width of 4, and a height of 7, and rectangular box K has a length of 3, a width of 8, and a height of 5, then the volume of box J is what fraction of the volume of box K? We see our answer choices are all fractions, so we're literally solving for the ratio here. So what we're asked for is the ratio of the volume of box J to the volume of box K. Well, again, we know that the volume is just length times width times height. So for the volume of J, it's going to be 2 times 4 times 7. And for the volume of K, it's going to be 3 times 8 times 5. Now simplify before you do all the multiplication. We can cancel out the 2 and 4 in the numerator using the 8 in the denominator. So all we really have is 7 over 15. And our final answer choice is D. Let's now examine cubes. A cube is a box in which all sides are squares. Every edge in a cube has the same length. So length equals width equals height. Therefore, to find the volume, we need only find the length of one side and raise it to the 3rd power. So the volume is equal to one side cubed. So let's try a problem. Let's find the volume of a cube with an edge of 4. If the edge is 4, we know that our volume is just going to be one of the edges cubed. So our volume is going to be 4 cubed, which makes our volume 64. Let's now apply this to an in-format question on cubes. If the volume of a cube is 64, what is the surface area of the cube? When we look at our answer choices, we've got numbers in ascending order. But since we're solving for surface area, back solving is not going to be a viable option here. We're better off doing the straightforward math. So we know that the volume of the cube is 64. Since we know that the volume of a cube is one side cubed, and we know that the volume is 64, one side cubed is equal to 64. So the length of one side is going to equal the cube root of 64, which is 4. Now that we know the length of one of the sides of the cube, we can solve for the surface area. we know that one square on the surface of this cube is going to have the area of side squared, which is going to equal 4 squared, which is 16. But that's just one square on this cube. All of the squares on this cube are going to be equal, and there are 6 of them. So we're going to take this 16 and multiply it by 6. When we do that, we get 96. One important thing to know is that the surface area of a cube is just going to be side squared times 6. So our final answer is C. Let's now examine another commonly tested solid, the cylinder. A cylinder is a uniform solid with 2 opposing circular faces. The surface area between the faces is the lateral area. The lateral surface area of a cylinder is equal to the circumference of the cylinder times the distance between the faces. Think of it like a label on a can. If you cut the label off and you unravel it, you literally have a rectangle. The length of that rectangle is going to be the circumference of the circle, 2 pi r. And the width of that rectangle is going to be the height of the cylinder. So the lateral surface area of the cylinder is going to equal 2 pi r h. So the surface area for a cylinder is going to equal the lateral surface area, 2 pi r h, plus the area of the 2 circular faces, 2 times pi r squared. To find the volume of a cylinder, find the area of one of its circular faces and multiply it by the distance between the faces. So the volume of the cylinder is going to equal the area of one of the circular faces, pi r squared, times the height. Let's try a problem dealing with cylinders. If a cylinder has a radius of 8 and the distance between its circular faces is 20, what is its volume? So we know the volume is going to equal pi times the radius squared times height. We know the radius is 8, so volume is going to equal pi times 8 squared times the height. And we know that the height in this particular instance, the distance between its circular faces, is 20. So the volume is going to equal 64 pi times 20, which is equal to 1280 pi. Let's try another problem. If a cylinder has a radius of 2 and the distance between its circular faces is 10, what is its lateral surface area? So we remember that lateral surface area is going to equal 2 pi r times height. And in this case, we know the radius is 2 and the height is 10, so our lateral surface area is going to equal 2 pi times 2 times 10, which is equal to 40 pi. Now let's take this information we learned about cylinders and apply it to an in-format question. A cylindrical container with a radius of 4 and a height of 6 is 1/3 full with liquid. If this liquid is poured into a second cylindrical container with a radius of 3 and a height of 8, then the liquid will occupy what fraction of the second container? At this point we see our answer choices. They're all in fractions. So we know we're dealing with some type of ratio here. So what we're really solving for is what fraction of the second container the liquid will occupy. So to know that, we know the denominator is going to be the volume of the second container. And the numerator is going to be the volume of the liquid. This is what we're solving for. So let's put this all together. The original cylindrical container has a radius of 4 and a height of 6. So we know the volume is equal to pi times radius squared times height. We know the radius is 4, so radius squared is 16. So the volume is really equal to pi times 16 times 6, which is equal to 96 pi. But it's not completely full. It's only 1/3 full with liquid. So the volume of the liquid is going to be 1/3 of this volume, or 1/3 of 96 pi, which is equal to 32 pi. So we know that the volume of liquid is 32 pi. This is going to be the numerator of our fraction. And our denominator is going to be the volume of the second container. The volume of the second container is going to be pi times radius squared times height. And since we know that the radius of the second container is 3, radius squared is 9, and the height is 8. So the volume of the second container is 72 pi. So now we take this and plug it into our denominator. And we know that the volume of the liquid over the volume of the second container is 32 pi over 72 pi. Well, our pi's cancel out, and we can reduce down 32 over 72. We can pull out 8 from both sides, and we'll get 4 on the top, 9 on the bottom, and our final fraction is 4 over 9. Our final answer is B.